Lesson 2A, we're going to talk about the different types of experimental design. So we have some vocabulary that we need to know first. All right, a factor. This is also called the explanatory, or in science, the independent variable. So this is the thing that we are changing. All right, so if you think back to our ping pong ball experiment, all right, the factor was your position. Were you seated or standing? Okay. In some experiments, we have different levels. So this is where we look at the same factor and we sort of change it around a little bit. So a lot of times this has to do with medicine. So if I have one pill that's a 200 milligram pill, and then I have another pill that's a 500 milligram pill, those would be different levels of the same factor because it's still the same medicine. Okay, and so when we get to a treatment, that's how are we combining the different factors in different levels, because there can be more than one factor in an experiment sometimes. Okay, so the easiest way I can think of when you're asked what is the treatment is what specifically were the people or things or animals in the experiment, what specifically were they given or doing? Okay, so in this case, the two treatments were sitting and standing in our ping pong ball experiment. Okay. The dependent variable is also, you might see it referred to as the response variable. This is the thing that we are measuring. Okay. In our ping pong ball experiment, that would be how many times did you get it into the cup? All right. What were we measuring to see if the treatment made a difference? Okay, and then experimental units, these are in science classes, you've probably referred to these as subjects. These are the things that we are doing the experiment on. So it could be people, it could be plants, it could be animals, it could be objects. Okay, what is actually receiving the treatment? Okay, some more vocab that we need to know. We should try our best to have some sort of control group in every experiment. So this is a group that either gets no treatment or gets a placebo. Okay, and a placebo is a sort of basically a fake pill. This happens a lot in medical trials. Okay, it has no medicine in it, but it looks like medicine. It's basically just like a sugar pill. Okay, and the reason we use placebos is there's something called a placebo effect, which is if I give somebody some sort of pill, they start to feel better just by taking that pill because they feel like some action has been taken. All right, so the reason we give a placebo is to see if the real medicine makes a bigger difference than the placebo. So, did this person actually feel better because of the medicine that I gave them, or did they feel better just because I gave them something and told them it would help them? Okay, so placebos are one example of a control group. And control groups are so that we have like a baseline for comparison and have something to compare our treatment to. Something else that we need to look out for is something called a confounding variable. So this is anything else besides our treatment that might affect our experiment. If, for example, we are testing some sort of medicine and we have people in our experiment from ages 18 to 80, okay, age could be a confounding variable there because people of different ages are going to react to medicines and they're going to be in different levels of health. There's all kinds of things that could be going on there. Okay. So when we have what we call a well-designed experiment, which means we did a good job with it, we're looking for three things: control, randomization, and replication. Okay, control is what can I do to eliminate or at least limit as much as possible the presence of or effect of confounding variables. Okay, so control is not just having a control group. Control is making things the same as much as possible besides your treatment. So in our ping pong ball experiment, you had the same ping pong ball, you had the same cup, you had the same desk, hopefully. You didn't change any of those things. between sitting and standing. So all of those things are examples of control. Keeping those things the same when you are sitting and standing, those are examples of control. Okay, randomization, randomly assigning the subjects to different treatment groups. Okay, this is an area where our ping pong ball experiment would fail. All right, but let's go back to our medicine example. I have one group that's going to get the medicine. I have another group that's going to get the placebo. I, as the experimenter, should not be picking who gets what because that could introduce some bias. So I should do it randomly. Use a random number generator, pick things out of a hat, something so that it is randomly decided who gets what treatment. And then the last thing is replication, which means that I have multiple experimental units receiving the same treatment. So I shouldn't do an experiment where one person gets the medicine and 6 people get the placebo. Because that one person, if they have some special characteristic about them, now I have issues. Okay, so I want to have a bunch of people getting the medicine and a bunch of people getting the placebo. So that any other variables that might come into play are kind of spread out evenly amongst everybody. Okay, 3 types of experimental design that we're going to look at in this class. All right, first is a completely random design. Okay, so this is exactly what it sounds like. We take our big group of experimental units and we randomly split them amongst the treatments. Okay, simple, convenient, easy, but if we have a group where things are sort of unbalanced, like if I have more females than males in my subjects, um, it's possible that if I just do things randomly, I could end up with the majority of the males in the same group. So if they all get the medicine, then do I know? I don't really know how well the medicine works for females because my group was mostly male. Okay, and so to kind of fix that problem, we can do what's called a randomized block design. All right, and so this is going to be similar to like our stratified sample. I'm going to split my subjects into blocks by some characteristic that I think is important to the experiment. So it could be age, could be gender, could be income, could be health, could be all kinds of different things. Okay, and then what I do is within each block, some people get both treatments. So here we have juniors and seniors, and we're going to see how they do on a test with either getting a practice exam or not getting a practice exam. Okay, if I think there might be some difference between juniors and seniors and how well they're going to do on this exam, I want to make sure that I have even groups of each. So I'm going to split the group into juniors and seniors, and then in each group, some of them get the practice exam, some of them do not. And then at the end, I only compare juniors to juniors and seniors to seniors. Okay. Our third type is called a matched pairs design. All right, and there's 2 different ways to do matched pairs. Basically, we're trying to make sure we're going to compare like 2 people, we're going to pair them up, and we want them to be as similar as possible. So a lot of times you'll see these sorts of experiments done with identical twins. And so one gets the medicine, the other gets something different, and we just compare the 2 twins to each other because they are genetically identical. That sort of eliminates other issues. The second kind of matched pairs design is when each subject receives both treatments. Okay, and that's what we did with our ping pong ball example. All right, everybody did it seated and everybody did it standing. Okay, and the reason for that is if I compare one person seated to another person standing, I don't know if the difference was the sitting and standing or if the difference was one of those people was just better at the game. Okay, so you have the same skill level. And so if we compare you sitting and you standing, it's a more even comparison. Now, the thing that we did not do in this experiment, which is always important when you do this form of matched pairs, is the order of the treatments must be randomized. Okay, so we should not have had everybody sit first and then everybody stand second, or the other way around. Okay, that order should be randomized. The reason for this is a lot of times, like the second time you do something, you might be better just because you've had more practice. Okay, and so did you get better because you sat down, or did you get better because you just had some more time to practice? All right, so that is it for 2A.